suppose that the greatest integer function f such that r to r given by fx is equal to greatest integer function is neither 1 1 nor on 2, where this symbol denotes the greatest integer less than or equal to x. By the way, how do you define this greatest integer function x? No doubt, theoretically he says greatest integer less than or equal to x. How do you take it numerically? If x is greater than equal to 0 but less than 1, the value of greatest integer function is 0. If it is greater than equal to 1 but less than 2, the value is 1. If it is greater than or equal to 2 but less than 3, it is 2. If x is greater than equal to negative 1 but less than 0, it is negative 1. And now let's check whether the function is 1 1 or not. Let x1 and x2 are any two real numbers in the domain of the function such that fx1 equal to fx2, and we want to check whether x1 will remain equal to x2 or not, where x1 and x2 are different. So let me prove with the help of an example. Suppose x1 is, take this interval, x lying between greater than equal to 1 but less than 2. Suppose x is 1 is 1.3 and x2 is 1.5. Okay, so if you take 1.1 and what is the value of fx? 1.3. f of 1.3, f of 1.3 is 1 and f of 1.5 is also 1. So that way this condition is satisfied that fx1 equal to fx2. Do you understand? f of 1.3 and f of 1.5 is same. But what about 1.3 and see, I repeat, f of 1.3 is same as f of 1.5 because each one of them is equal to 1. But 1.3 is not equal to 1.5. That means there are two real numbers in the domain which have the same image. So the function f is not 1 1. It is not 1. Now to check onto. How do you check onto? That is, to each real number in the codomain, let me choose a number 2. 2 belong to R, 2 is a real number in the codomain. So what is that real number x such that fx is equal to greatest integer function x equal to 2? Sorry, please don't take 2 because you know the images are the integral points you observed lying between greater than equal to 2 and less than 3. Take it as fraction. Suppose you take 3 by 2. Please make a correction. Let 3 by 2 is a number in the codomain such that the fx greatest integer function x is equal to 3 by 2 instead. So do you find any number such that the value of greatest integer function is 3 by 2? No. Because whatever real number you take, what are the images? The images are 0, 1, 2, 3, negative 1, 2, 3, only the integral points. Look at the definition. Look at the definition please. Here you find 0, 1, 2, 3, negative 1, 2, 3. So it is never 3 by 2. So we conclude that y equal to 3 by 2, which is a real number in codomain, does not have a pre-image in set of real number, that is the domain, and hence the given function f is not onto. So it is neither 1 1 nor onto. Alternatively, let us see the graphical situation. If fx is equal to greatest integer function x, you have already defined that it is 0 when x is greater than equal to 0 but less than 1. It is 1 when x is greater than equal to 1 but less than 2. It is 2 when x is greater than equal to 2 but less than 3. It is minus 1 when x is greater than equal to negative 1 but less than 0. Look at the graph. At x is equal to 0, it is 0. I make it here 0. But at 1, it is not 0. So make a hollow point here like this. So from 0 to 1, 0 to 1, x is greater than equal to 0 but less than 1, it remains 0. And what is the value at x is equal to 1? The value at x is equal to 1 jumps to 1 and it remains 1 till 2 but not at 2. At 2 it is 2. Okay. And it remains 2 till 3 but not at 3. Similarly, at negative 1, the value is negative 1 and it continues to be negative 1 till 0, but at 0 it is not negative 1 but 0. Now look at the graph. How will it help you to check 1, 1 and on 2? See, let's take this segment that is from 0 to 1. There are so many points here have the same value, same image, that is 0. Similarly, in this segment, whether you take 1.1, 1.2, 1.3, 1.999, the value of the function remains the same. That means it is many one function. And what about on 2? There are so many gaps. You can have the image only at 0, 1, 2, only at the integral points. If you take any non-integral real number, say you take 0.01, 1 by 3, 2.7, then there is no value of x corresponding to it. Do you find here? Suppose I take 2.5 corresponding to 2.5 or I take 1.5 corresponding to 1.5, there is no value of x on the curve, there is no point on the curve and hence it is not on 2. So it is neither on 1 nor on 2.